Greetings! We're going to try to find the area of sectors and also the lengths of the arcs that are the boundaries of those sectors during our lesson today. Here's how I think about it, and I hope this will help you in your solution process. We have an example of a problem here on the left. This image shows a circle with radius and central angle measurements. So I'm going to need to identify what those radius and central angles are. They're demonstrated in the picture. What they'll have me do then is I need to find the area of the shaded sector. So I'm assuming that's the blue part. And the length of the arc defined by the sector. When we talk about an arc defined by a sector, what this means is the arc whose measure is the same as the central angle for the sector. So to start out with, I'm going to think about area. When I'm doing one of these problems, there's some basic data I want to collect. So for the circle, I want to record what its radius is. And then I'm going to use that to quickly compute for myself what the area of the entire circle is and what the circumference of the entire circle is. So in my picture, I noticed that the radius, that's always that distance from the center to any point on the circle. So that's this distance here that I'm highlighting in green. It's 5 inches. My radius is 5 inches. Then using my SAT reference sheet, I can remind myself that the formula for the area of a circle in general is pi, that number that's about 3.14, times the radius squared, and that the circumference of a circle is 2 times pi times the radius. And for that reason, I can now compute the area and circumference of my particular circle by substituting 5 for the radius. So let's do that. Our area in our example, and I'm going to call it area subtot to remind myself it's the total area, is pi times our radius, which was 5 squared. So that's pi times 25. And our tradition is to write the number in front of the pi. So 25 pi. Because 5 was measured in inches, I can give this the units of square inches. Expect for a nice big fat 4 on a problem, I need to include those units. Next, let's look at circumference. Circumference here we have 2 pi r. So for our total circumference, I'm just going to use a c for that. 2 pi times my 5 inches, or 10 pi inches. So those are those 2 measurements that I'm going to need to solve this problem. Here's the last step. I just need to figure out what fraction of my total circle I have shaded. And then exactly that fraction of the circumference is what I need for the arc, and that fraction of the area is what I need for the area of my sector. So in my shaded problem, what's my angle? That's the next question. My angle is 160 degrees. We'll also be exploring these in terms of radians, which is a measurement that's just directly related to proportions of an outside of a circle when we move into class on Tuesday. For that reason, let's make sure we always label that this is degrees when we're doing an angle so that we know which ones we're in. Now, here's what I want to do. What proportion or fraction of the circle am I talking about? I just have to remind myself there are 360 degrees in a circle. So to do the proportion of a circle for my sector, I'm going to take my angle and divide by 360. So what's the ratio of the whole circle, of the part of the circle that I care about, to the whole circle? That's this calculation. So in this case, I'll give us a decimal approximation, but you can always use fractions as well. That decimal is 160 divided by 360. And that is 4/9 or 0.44. So I'll write it as 4/9 here. You also could just leave that proportion in its original form. So to finish this question, my sector area should be my proportion times my total circle area. So in this case, 4/9 times my 25 pi inches squared. And that calculation, if I replace pi with 3.14, this is about 34.89 square inches. Then for my arc's length, the arc we're talking about here is the arc that goes around that shaded sector. So I'm highlighting it in orange here. My arc length, I'm going to take that same proportion, 160 over 360, and I'm going to multiply it by the circumference. So we get 4/9 times 10 pi inches, which is 40 pi divided by 9, about 13.96. So what I'm saying here is that I would need 34.89 square inches of paint spread out to fill that portion of this particular circle. And what I'm saying is that if the circle were drawn to scale, that in order to wrap around the portion of the circle that we've shaded in blue, just that portion, I would need an arc whose length was 13.96. I could take a piece of string and measure that portion, and I would need a length of 13.96. So those are my steps. Get the radius, compute the area for the whole circle, and the circumference for the whole circle, if I'm trying to get both. And then whether it's area or arc length, I just take the proportion of my angle to 360 degrees. And that's the fraction I'm going to multiply my area or circumference by.